Welcome back to College Algebra, and today we're starting our series on the basics of college algebra. So this series has less to do with what we traditionally call algebra, and that is solving for x and working with variables. Instead, we're going to go back and talk just about how numbers and quantities work in general to help us kind of become prepared so that we can be successful in college algebra. Today's discussion is on something you've probably known for a long time, and it's the order of operations. But I'm going to give this a subtitle because order of operations doesn't really describe what we're trying to do. What we're really trying to do is get the correct answer with your calculator. Because most of you, if I give you a problem, will be able to do the order of operations correctly. The challenge is going to be making your calculator do the order of operations correctly. So when we say order of operations, I think most of you know what I mean. You've probably seen before the phrase PEMBUS, parentheses, exponents, multiplication, division, addition, and subtraction. I'm not really big in memorizing this, although I think that after you work for a little bit in the world of mathematics, these things become kind of natural and second nature. In reality, you could do all operations using only parentheses, but we in the world of mathematics have chosen to leave off parentheses frequently in our problems, and this is just a convention that we've developed, that if you leave off parentheses from multiplication and addition, then we choose to do the multiplication first and the addition second. Some people, you've probably heard a bunch of acronyms. I think the most popular is Please Excuse My Dear Aunt Sally or Susan. I guess you can come up with some other name, maybe Samantha. Okay. One quick note that I would make is that when I look at these, I think of multiplication and division as the same idea, just different sides of the same coin. And so as long as you're careful, you can actually just group these as one idea. So the first thing we do is anything explicitly stated in parentheses. This explicit statement also includes things like inside a logarithm or things like inside a square root, so things like that. Anything kind of explicitly stated, we have parentheses. Often we will have implied parentheses. For example, when we have fractions, they'll be implied that what's on top and on bottom of the fraction are in parentheses, but we won't write them. The next thing we do is exponents when they're available, multiplication and division, and the last is addition and subtraction. And just like multiplication and division, I view addition and subtraction as two sides of the same coin, and so you could group them together in your mind, being a little bit careful, realizing that subtraction has a multiplication by -1 in it, and so you have to be a little bit careful and not extend that multiplication to other parts of the problem. But I think if you group them in your mind, you see there's really not too many things to think about. So let's talk about just the most basic type example we can get, and that's something like this. 3 times 2 plus 5. My guess is that most of you are capable of doing this, and we can go through our order of operations, and we can look and we can see, oh look, we have a multiplication and an addition. Which do we do first? Well, you multiply first to get 6, and then you add second to get 11. Like I said, most of you I think could do this just fine. As I said earlier, we do have parentheses in this problem, we just don't write them down. If someone had wanted, they could have written down parentheses right here, which tells us that those two go first, and then we could have written maybe even a bigger set of parentheses that says then you do the whole thing. So parentheses are always present. It's just in the world of mathematics we've chosen not to write them down in cases where we do the multiplication before we do the addition. Okay, but as I said, the real challenge is usually not getting you to compute the answer. The real challenge is getting your calculator to compute the answer, because that's where order of operations is usually going to throw you off. And the reason is because the calculator follows these set of rules very carefully and always does exactly what you tell it to do. So let's look at an example where it might be easy to get the wrong answer using your calculator. We'll do 3 divided by 4 plus 2. Now, if I do this by hand, we can see what the answer should be. 3 divided by 4 plus 2, it might be tempting to say you do the division first, but there's an implied parentheses in the bottom of the fraction. We don't write the parentheses down, but they're there, they're understood to be there. So everything on top of a fraction, everything on the bottom of a fraction are implied to be together in parentheses. So when I do this, this becomes 3 divided by 6, which we can see really quickly is 1/2 or 0.5. So when we put this in the calculator, we would expect to get 0.5 in our calculator. Now, let me show you what might happen if you type this in. If you type this in but don't do it properly, you might do 3 divided by 4 plus 2. Now if I type this in, what should I expect my answer to get? Should I expect to get 0.5? No, in fact I got the wrong answer. I got 2.75. So what happened here that gave me the wrong answer? Well, what happened was that I missed those implied parentheses right there. So if I switch my problem and do 3 divided and put in parentheses 4 plus 2, now I get the answer that I expected. I get the 0.5. So you see, without the parentheses, the calculator very literally does the order of operations and says do the 3 divided by 4 first, then add 2 to it. So 3 divided by 4 is 0.75, and then add 2 and get 2.75. So you have to be very careful when talking to your calculator to always tell your calculator to do the order of operations in the order that they should occur. And so you need to include this 4 plus 2 in parentheses to make sure that it does that addition before it does that division. The next problem is, what do we get if we want to take -3 and square it? Well, if you think about it, what is -3 squared? -3 squared is the same as -3 times -3. And I think we know what this answer is. Well, 3 times 3 is 9, and we have 2 negative signs, and so that becomes a positive sign, and so 9 is our answer. Now, what would happen if we tried to use our calculator to do this problem? If I grab my calculator again, and I do -3 squared, and hit enter, I get -9. But that's not the answer that I got, that I know it should be. I know it should be +9. So why did my calculator give me a -9? Well, the answer comes in that what I wanted is I wanted to take -3 and then I wanted to square it all to get +9, versus what the calculator saw was -3 squared, which means that you have this negative sign and then the 3 squared. So if we use our order of operations, what comes first? The square comes first, so we square the 3 to get 9, and then we multiply it by the -1, which makes it -3. So if you see, there's a multiplication and a squaring, so you have to be very careful to tell your computer to do that, to tell your calculator to do that multiplication first, so that you don't get the wrong answer. So notice, if I took my problem and I put the -3 in parentheses like I expected, and then squared it, then I would get the correct answer, which is +9. So that parentheses makes a big difference. So the big point that I'm trying to make with this order of operations is your calculator will always follow the order of operations, whether you intend it to or not. So it can't read your mind, it can only do exactly, explicitly what you tell it to do. Let's now work on a problem that's quite a bit more complicated. And it has a square root inside of a square root and a fraction. Let's try to write this out using our calculator to get the correct answer. I'll go through it, and then in a moment we'll have some other problems for you to try at home to see how successful you are. As I look at this, what I notice is that we have a bunch of things that have to be done first. So we have a square root, and then we have a 1 plus, and then we have a square root of a 5 divided by 2, and then we have all of this divided by 10. So as I look through all these elements, I need to ask myself, well, what happens first and what happens last within these elements if I want to successfully type it into my calculator? And as I look through, I realize, well, oh, so the most inward parentheses is this 5/2. This 5/2 has to be the very first thing that happens before I take that square root. So this 5 and this 2 have to be in parentheses when we divide them by each other. And the next thing I notice is that we have the second square root that has the 1 plus the 5/2 all within them. And so what you'll see is that we have to have the square root, we have to have all of these things put together, and then we divide it by 10. It might not be a bad idea to even add another layer of parentheses on here, although because square root is considered an exponent, they'll do that square root before they do the dividing by 10. But it might not be a bad idea to be careful and put even one more layer of parentheses outside the square root just for care. Let's do this on our calculator and see what we get for our answer. So as I do my calculator, I'm going to come here and find my square root button. And so to do this, I'm going to have to hit second square root. And notice the calculator, my calculator, is nice. It suggests that I use parentheses because it knows people tend to make a mistake of not including the things inside the parentheses. Your calculator may or may not do this. So we'll do square root, and we'll have 1 plus, and then we'll have our second square root, and then we'll have 5 divided by 2. Then we'll close that parentheses, and then we'll close that next parentheses, and now we've got the square root of all of that stuff, and then we divide this by 10, and we get our answer, which appears to be 0.1606 or something, 7. Maybe I should have rounded up. I'll be fine with this. I try not to get too stressed out about rounding. Let me show you, however, another way of doing this, and it's the way we might do it if we were to do things by hand. And so if we were to try to solve this problem by hand, what I would probably do is start computing inside out. This looking at the problem and seeing it as having an innermost part and then a next level part and then a most outside part is going to be very useful when it comes to solving equations. Because when we solve equations, we often undo the equation starting with the outermost part first and working our way inside. So being able to see equations as having an innermost parenthesis expanding out to the outermost part is actually going to be quite useful for us. So as I look at this problem, I might want to solve it like this. Might want to solve it as first, we'll do the square root of 1 plus the square root. Well, if we divide 5 by 2, we get 2.5 divided by 10. And so all I really did was I took this innermost part, which is this 5/2, and actually computed that number to get 2.5. Now as I look through, the next computation to make is going to be the square root of 2.5, which I will have to grab my calculator in order to compute that because I can't do it in my head. So I'm going to grab my calculator and do the square root of 2.5 and get 1.5811 for that answer. So the next thing I will write down is square root of 1 plus 1.5811, all divided by 10. The next thing I might do is now add. So as I'm looking, I see that my next operation to occur is right here, is this 1 plus 1.5811, and that will give me square root of 2.5811 divided by 10. And now, as I look through this problem, I see the next thing I want to compute is I want to compute this part, and let's go ahead and move to the next line. And as I compute this part, I need to do 2.5811. Oh, I forgot my square root. 2.5811. That's going to give me 1.606. 1.60665 will be just okay, that'll be just fine. 1.6065 will be just fine. That's that top part, and now we divide this by 10, and so we'll go 1.6065 divided by 10. I probably could have done this in my head because I know when you divide by 10 it just moves the decimal place one spot, but let's go ahead and do it in our calculator and get 0.1605 for our answer, which is almost the same as what we got earlier. The only difference was a little bit of rounding. This idea of thinking of the problem as the inside working out is actually really helpful. And if you find yourself really struggling getting your calculator to do what you want, this is actually a nice way to go about it. Just working the inside out, write out what the calculations are, because intuitively we tend to do a really good job of understanding order of operations and thinking through them correctly. The problem is when we try to translate that or speak those order to the calculator, we often tell it the wrong order to compute. Okay, let me show you one last thing that I really like, and you may already know about it, but if you don't, you'll appreciate this feature. And it's when we look at this calculator, the calculator has the answer button, which allows me to start by taking 5 divided by 2 and hit enter. And then I can do the square root, but instead of typing the 5.2, I can just type my answer button. And most calculators have a way of just inputting whatever the previous answer was into your problem. And so this lets us work inside out. So we take this 5/2, we take the square root of it, and that gives us this. And so now we're this part, so we're going to take that number and put +1. Notice that when I put the plus sign, my calculator knew that I wanted to add it to the answer, so it added that previous answer. So we'll take the previous answer and add 1 to it, and that'll give 2.5811. Now we're going to take that answer, which is that, and square root it. So I'll take the square root of that answer, which gives me the square root of the 2.5811, which gives me the 1.6065, and then finally for the last part I'm going to divide that by 10. And as I divide that by 10, I get 0.16065, which actually was the exact same answer we got right there. So that's just a nice little technique. If you like, you can use this answer button to run your way through the problem if you're struggling getting it typed in correctly. Okay, now, as I usually like to do when we end the class, I would like you to look at 2 problems. We have problems with some fractions and some squareds and some problems, and I'd like you to use your calculator and to try to compute these answers correctly with your calculator. As always, I want you to pause right now, pause your device, take a quick break, try these problems on your calculator, and then come back and let's see if you got the right answer. Okay, we're back, and the answers I got were 62 for the first problem and -24.6 for the second problem. If you didn't get those answers, or if you just want to see how I think about the problems, you can look over here on the right and you'll be able to see my solutions to these 2 problems. Thank you very much. When we come back next time, we'll start talking about decimals and how to work with them effectively.